Hey guys, I hope everything's going well for you today. I'd like to introduce matrices today and some basic matrix operations. Matrices actually allow for a shortcut to be able to solve the systems of equations that we did last week. I don't know if we'll make it that far into the unit this year or not, but it definitely is a shortcut there somewhere for us to find in the future. First of all, a matrix is just a rectangular array of numbers that is usually named by a capital letter, either A, B, or C, or so forth. Each entry in a matrix is referred to as A sub ij, such that I represents the row and J represents the column. We're going to see that same order keep coming up, row and then column. Okay, and then we can also talk about their dimensions. Dimensions today aren't going to play a huge role in it as much as the next video tomorrow. But when we talk about the dimensions, we talk about a matrix being m by n. We're talking about its rows by its column. So I always just remember RC. There was an old soda that I used to drink. You can get it coming out of Walmart whenever I was little. It's called RC Cola. So I always just remember RC Cola, rows by columns. And we're talking about rows. We're talking about all the numbers that are horizontal. And each column would be the vertical set of numbers. So let's just look at this matrix right here. Not a great question to start off with. I probably should change it. But it says, what are the dimensions of matrix A? So looking at this, I'm wanting to describe it by its rows and columns. Well, it happens to have the same rows and columns. So it's just going to be a 3 by 3, where this first 3 represents the number of rows that it has, 3 going down. And then this other 3 represents the fact that it has 3 columns. Okay. And then it wants to know what the entries A sub, I don't know if that'd be A sub 12 or A sub 1, 2. Either way you want to call it. I'll call it A sub 1, 2. A sub 1, 2 would be, let's see, this first one right here, this first number is going to go with the row, and this 2 right here goes with the column. So I'm going to look at the first row, and then the second column. And so the number that's in the first row, second column, this would be this 1. So A sub 2, 3. Again, it goes rows by column. So we're talking the second row, and then this 3 right here is the third column. So second row, third column is this 0. I might refer back to that as far as a specific entry, and that's how I will word it, A sub 1, 2, or A sub 2, 3, or A sub 3, 3, however I need to. Big thing I want to get done today is be able to add, subtract, and do scalar multiplication on matrices. So to add or subtract matrices, they must be of the same order, n by n. So their dimensions must match exactly. So we just had a 3 by 3 matrix. I can't multiply a 3 by 3 matrix by a 2 by 2 matrix. It doesn't work. Okay? And the reason it doesn't work is because I'm adding or subtracting their corresponding entries. So if I have a 3 by 3 matrix, I'm going to have 9 entries in there. Whereas if I have a 4 by 4 matrix, I'm only going to have, a 2 by 2 matrix, I'm only going to have 4 entries. So not all the numbers are going to be able to correspond to another entry. And so here's the notation I'm going to be using. I'll be using capital letters for my matrices. And then like I said, the I's and J's have to match. I'm just adding corresponding parts there. So let's look at these two matrices, A and B. Looks like first I'm going to just simply add A plus B. So I'm going to overteach this just a little bit. I'm not going to copy down A plus B, but keep in mind, before I even get going on this, today and tomorrow would be a good idea to check your dimensions first to make sure that it actually does work. So if I check the dimensions on A and B, I get that they're both a 2 by 3. They have 2 rows and 3 columns. So I feel good about adding them because they match exactly. So now that I see that they match, I'm just going to add their corresponding entries. 5 plus 3. And then I just go to the next corresponding parts, 10 plus 8. I go to the next one. I'm going to run out of colors. 20 plus 5. And now I go to the next one and the next one. So 8 plus 2, 6 plus 9, 5 plus 3. They all are matching up to what's in the same spot that that number is in on the other matrix. I'm going to look at adding them up. So it just gives me 8, 18, 25, 10, 15, and 8. That would be my matrix. Notice it is also a 2 by 3 matrix, same as what I started with. The dimensions won't be changing today. So you try the b minus a, hit pause, and just make sure your numbers and your dimensions match with what I'm about to put up. Just about messed that up by doing a minus b. Make sure you're getting them in the right order. We'll look at b first and subtract off the corresponding a. So subtraction does matter which one comes first. Hopefully you got this. The other operation I want to talk about is scalar multiplication. Scalar is just a real number quantity that has magnitude, but no direction. Okay, we talk about vectors have magnitude and direction in geometry, or later on in pre-cal we'll also talk about that. But for now, a scalar is just a number like 7 or -3 or 10 and a half. It doesn't have to be a nice number, but it's just a real number quantity that is just has magnitude but no direction. And so whenever I'm looking to multiply by a scalar, what I'm going to do is I'm just going to multiply each entry by the scalar. Okay? Multiply each entry in the matrix by the scalar. So it looks a little bit distributive whenever I do this. So if I'm looking at finding -4b, let's see, -4b is just going to be -4 times. It's going to be one of those rare instances where I actually bring down b, so I can kind of illustrate what's going on here. This 4 is just multiplying to every term that is, or every entry that's in the matrix. Careful with the signs, don't go too fast, be tedious with it. It's not going to take very long to do these problems. What I like to do, and what you're probably going to see on the assessments from me, is a mixture of the two. Okay. So if I'm looking to find the following, 4b minus 2a, I still want to obey the order of operations. If I see parentheses in there, I want to do it first, and I want to do any multiplication before I do any addition or subtraction. So my scalar multiplication will be one of the first things I do if I don't see any parentheses on here. So on this one, it says take 4 times b. Well, 4 times b is just going to be taking this 4 and multiplying it by every term in this b. So I'm going to go ahead and write that out so I'll have those numbers in front of me. 12, -8, 0, 4, -4, and 32. Now from here, there's 2 different things that we could do. We could actually distribute a -2 through the a. If you do that, make sure you put a plus sign because you distributed a negative. I'm not that brave, okay? I'm just going to distribute a 2 through matrix A, and I'll just subtract my matrices. Okay, so if I distribute a 2 through matrix A, -12, 10, 0, 4, 6, and -2. It's a great question. It combines everything that's I'm trying to do in this video in one problem right here. So now, I'm just doing some subtraction right here. Okay, you could think to pull through a negative if you want to. I'm not going to do that. I'm just going to subtract my numbers. I'm going to take 12 minus a -12, and call that 24. I'll take -8 minus 10. That's -18. I get 0 minus 0 and 4 minus 4. -4 minus 6 is a -10. 32 minus -2 is 10. And again, notice my dimensions match on these. Everything on here is a 2 by 3. And my final answer is a 2 by 3. A little check on yourself to make sure that you did not skip anything. That's really all I've got for today. The next video will cover multiplying 2 matrices together. It'll be a little bit trickier, but go ahead and practice on these problems and we'll pick up from here tomorrow.